Hello, everybody. Let me get the camera going here. And there we go. So, thanks everybody for showing up. I'm Eric. This is first for me doing a webcast like this. I have been a trainer here at Cincinnati for just over 9 years. It's my pleasure to bring you this information. So what we're going to be talking about, obviously, is the bend simulation software. This does assume that you have either a Cincinnati brake and the offline software, which if you do not have, it is available from our website under the software section. You can download a free demo that is useful for 60 days. After 60 days, you get the link that says, hey, by the way, your free trial is over. You need to buy it and then move forward. So I am running version 5.0.4.5, which I believe is current to just late last year, August of 2019. I know they're talking about a new version, but it's not released yet. So this is the latest stable revision or stable release that we have. If your software is slightly older, it may not look the same. Your colors will probably be different. You may not have as many options that we have, but the layout will be nearly identical regardless of which version you are using. So once we get, well, now that we are started, first thing I'm going to do is I'm going to go through the menus at the top of the screen. I'm only going to go through the menus that you're likely to interact with as an offline programmer. There are hundreds of menu options, and I've only got 2 hours, so I don't want to get too bogged down into things that you as offline programmers would be encountering. So, and again, the website for the software, www.e-ci.com, and you should see a link or one of the website browser links for the software, and you're going to want to look for press brakes. Okay. All right. So starting out at the top of the screen, again, just basic software familiarization. We've got the file menu, new program, open program, save program, which is going to be the same as these buttons here, new, open, and save, same function. We do have a setup page, a job setup page. It's a very basic job setup page. Basically, it's going to have the layout for the tools, and it's going to have your spreadsheet. Some useful information. I find that most of the customers I interact with will actually be using their own job setup sheets. So it does have its usefulness, but I'm not aware of any of the customers I've interacted with using them. We do also have the last 4 programs that were accessed on this particular machine. So in my software on my laptop, those are the 4 programs that I looked at last. Can be useful for trying to figure out, hey, where was that program you were looking at? Things like that. So, and then of course exit, which we don't want to do right now. Edit, copy, paste. You're not going to use it. I'm not aware of any functionality where that would be overly useful. You can copy information from one program to another program, but I find it's just easy to save as and then edit the save as actual program. Utilities, calculator, well, every single numeric field in the software turns out to be an actual calculator. So if you're trying to calculate something, if you're at the machine, hey, I've got a calculator right there at the screen. So a lot of my operators you'll see actually carrying a calculator around in their pocket, or they'll get out their phone and start typing into their phone. Well, we give you calculators on the screen, so you don't actually have to whip out your phone in the middle of a production job. Utilities convert. We do have the ability to convert older style programs over to newer style programs. We also have the ability to convert from one type of machine to another type, or basically a back gauge from one gauge to the other gauge. I'm not a huge fan of the convert utility, simply because most of the time it's simpler to write a new program from scratch rather than trying to convert an old style program to a new style, but your mileage may vary on that. Archive tool copy. If you have purchased Wilson, Wela, Mate, or Cincinnati precision ground tooling, we do have an archive of all of those preloaded into your machine. And again, depending on the age of your machine, you may have just the Wela and Wilson. If it's a brand new machine, if within the last year or so, you will most likely have the Cincinnati tools, and you may even have the Mate tooling. This is literally just there so that you can have, if you buy those tools, you can go to the archive and you can copy them directly in. So this archive tool copy here is going to be the same as the tool library copy archive function. So they both do the same thing. They both go to the same location. In this case, you can see I'm using, I'm in the archive folder for the upper tools. I'm referencing Wilson American Tools. If I'm going to switch that, and this is kind of an aside for where we're at, but if we're going to switch that, then we simply browse. And if I wanted to go to the Wela tooling, I would go to the Wela tooling. So these are all of your standard Wela upper tools. Some of you may recognize those numbers, some of you may not. I'm just going to stick with the Wilson for the moment. Okay, so that is the copy archive function. Now, language. We do have the ability to put the machine into Spanish and, in this case, Portuguese. Now, this is a fairly new function for the Portuguese, and we've actually moved the menus around a little bit. If you have an older version of the software, say 4.7, 4.8, 4.9, the language function is actually up here in the main menu between the maintenance and the view, or between the view and the help. I forget which. The reason I bring that up is because it is possible to switch the operating language of your software. And I have had many a phone call and or email saying, hey, what happened to my machine? It's in Spanish. How do I fix it? There it is. In the newer versions of the software, if you click on the Spanish, it will actually say, hey, we're going to change the language. Pressing OK will change it. Cancel will abort the change. And the new software application will automatically restart. In the old software, that did not happen. It said you must restart the software. So it is possible for me to click OK in the old software. It'll change the selection, but it's still in English until I restart the machine or software. And then all of a sudden, the next time you turn it on, everything's in Spanish. So I'm only pointing that out so that everybody's aware. I've worked on plenty of other machines where the interface suddenly changes to some foreign language and I have no idea where the menus are. Well, in this case, under utilities, language. The maintenance menu, from the offline perspective for programming, the only thing I'm really going to look at here is the configuration. So from maintenance configuration, I click on this and it opens up a new window. And you can see here across the top, there are a bunch of tabs. I have preferences, preferences continued, general, gauges, CAD dimensions, preferences, all the way across. If you are at the machine, the options at the machine will not be the same as in the offline software. In the offline software, I am logged into the software as the administrator, meaning I have the keys to the kingdom. I have access to just about everything, depending on my computer settings. Changes made in the offline software will not be reflected at the machine. Now, when we're writing programs, when I get up here to the CAD preferences, when you are writing programs, the preferences here will affect the program you create. But again, when it gets out to the actual floor onto the machine settings will override any settings that you have put in here. Okay, so preferences, again, not a whole lot that I'm going to go through here. Yeah, these settings are going to be per user. I will go to preferences continued. If you are using our offline software and it's 5.0 or later, there is an option up here for miscellaneous, allow widescreen display. This may or may not have been checked when you installed the offline software. So when you might have a 16:9 display, but the actual software is showing up at 4:3. So you may want to select that widescreen display, and then you have to restart for it actually to show up widescreen. General, I will point out here, we have a configuration utility that you can actually bring your machine configuration in. If you go out to your machine, open up the Windows Explorer, again, some of your machines will vary. The older the machine, the more likely this is going to be in a different location. But if you go out to one of our newer machines, you go to the D drive press break folder, and that's just literally my computer, D, press break. And then in the search bar, you're just going to type in CFG, and it'll find all of your configuration files. So, oh, I need to share that. That's not going to work. Yeah, so D, press break, and then you're going to do a search for the actual configuration file. And again, just CFG is the lettering you type in. It'll bring up all of the available configurations. And then as you can see here, I have a whole bunch of different machine configurations from the various customers that I have been to. That's how you bring in your config. Import AFPC. If you are at the machine, you can export, but I find it's just easier to go into the Windows menu itself and look up the items from the Windows menu itself. And again, if you have questions about that, how to do that, I do have an offline form. We can go over that offline. I can email that out to anybody who's interested in that. So general, this is your machine. In this case, this is the generic machine that I created for this presentation. As you can see, my serial number is 1, and then I just generically entered these numbers in. Yours will come from your machine. You can either look at literally your machine configuration file and type this information in manually in the offline software, or you can import your actual machine config. Gauges will actually come from your configuration. I'm not messing with any of that. I will say, if you are using an older machine, if you import an older config, or you're using older software, like I said, 4.9 or older, these Axis Comp checkboxes here will cause a whole bunch of error messages to pop up on your screen. Unable to locate Axis Comp, X-axis, R-axis, Z-axis, and then left, right, and Z left, Z right. I'm sorry. X left, R left, Z left, and then X right, R left, Z right. All 6 of those will pop up. The way you get rid of those is unchecking these boxes here, because in the newer software, we've removed the check value to say, hey, look for an actual gauge. It's going to get rid. It's not going to look for those comp files. But again, that's only if you see those Axis Comp error messages when you first launch the software. I'm not really going to mess with anything else here. Again, as an offline programmer, this is coming from the software, so you're not going to generally look for these, okay? CAD dimensions, again, these come from your machine. The one thing I will point out, in some of our older software, when they enter these values, what I have discovered is these A, B, and C values may not have been entered exactly correct. Now, A is critical. A has to be in for your machine to bend correctly. If that A value is wrong, your angle correction values are going to be off the chart. I mean, I've seen those values be as far as, and usually it's when somebody's messing with the values, either a serviceman or a maintenance technician at the company who is actually trying to troubleshoot something. They change that A value, and it again throws your angle correction values way out of whack. That right there, micrometer, actual height vertically of the filler block itself. Now, what I have found is the B and C dimensions do not affect bending. The machine does not care how wide that filler block is for the purposes of bending metal. It does, however, affect the way the bend simulation software, the offline software, will try to look for interference. So if I've got a 2-inch wide filler block, but the machine thinks I've got a 4-inch wide filler block, and I've got a part hanging down over the back of the die, clear of my physical filler block, but the machine thinks, the software thinks that filler block is wider, it's going to show an interference because it thinks the filler block is this wide instead of this wide. So what I would do is, if this is an issue, I'm going to go down to the physical machine. I'm going to measure the filler block with a pair of calipers, okay? And I'm going to get the B dimension. 99.5% of the time, the C dimension will literally just be half of the B. I have seen custom filler blocks where they put the slot offset, or they literally grind down the back of the filler block so that the front half was there, but the back half is ground down. So literally C might be less than or more than half. It's rare, but I have seen it. So let's say that my filler block is actually 2 inches wide and it's center line. So the B dimension is going to be 2 and the C dimension is going to be 1, literally just half of that dimension. So this is what you're going to want to look at. It's only really going to bother me if I have downward hanging flanges, but that happens all the time. None of the rest of this is going to be anything I'm going to worry about as an offline programmer. Now, CAD preferences. Now on this screen, this is where all the magic happens. I'm going to go down the left side, I'm going to go down the center, and then I'm going to go down the right side. So on the left side, rotation angle increment, there are arrows in the CAD software that allow me to do rotation, the view rotation of the part. I will show you these when we get into that, but for the moment, I don't mess with any of that. Graphics detail high, yes. Part labels, yes. Most of this here we're going to leave alone. You're going to want to have a pretty good reason for changing that if you do change any of these values here. Now down here in the color preferences, the one thing that I like to do from the factory default, okay, actually I think this one is like magenta, I like red, but the part color, so if you scroll down about 2/3 of the way, maybe 3/4 of the way, you're going to see part color and part bottom color. So when I display a part, most of the time face up and face down do not matter, but in the instances where face up, face down do matter, it's a critical issue. So right now, the upper and lower are the exact same color. So what I'm going to do here is I'm going to change the bottom color to something distinctive, so that if I look at the part, I can see, hey, this is up, this is down. At a glance, I can literally look at that part. If I see the green bluish color, then I know that that is bottom up, and that's a down bend. And then if I see the gray, then it's an up bend. So just what I like to do, set these to whatever you want to make it work better for you. There is always the reset defaults here, which will set your color scheme back to default. Up the very top center, bend simulation preferences. I have pinch point dimension. So when we start talking about a pinch point, the pinch point is defined as the part coming up, and if I have the ram here and the part is bending and it comes up and it makes contact or gets really close to the actual ram, that is designated as a pinch point. That is a hazardous location. By default, the pinch point dimension in the software is going to be 1 inch. Now, what that means is when I am trying to generate an actual part, I'm going to generate simulations, and this is something we will see when we get into the software. I hit generate simulations. It's going to look at the profile for both the punch and the die, and it's going to look to see, does the part actually interfere somewhere between where the punch comes in or where the die comes in. So if the part runs into the punch, you're going to get an interference message. But since I have the pinch point set at 1 inch, if the part comes to within an actual inch of either the punch, the die, the ram, the filler block, the clamp adapter, whatever it is you're using, if the part comes to within an inch of that location, it is not going to give you a valid simulation. So it's going to completely disregard that. So for the purposes of programming, all right, I am going to set that pinch point to its minimum value. And I will point out, if you look at this, you can see I have a range of 0.001 to infinity, basically. I'm going to set this value to 0.001 so that I can have the maximum possible simulations. It'll come up, it won't touch, but it'll give you that 1/1000th of an inch clearance. If I have that single foul between where the corner of the part is and where the ram, bed, filler block, tools, whatever is, I'm good. It'll clear. It'll give me a valid simulation. Then it's up to me, either as the programmer or me as the operator, to say, hey, looking at this visually, that part comes up real close and almost hits the ram, so that could be a pinch point. That could be a safety concern. You may want to leave that at 1 inch. If you leave it at 1 inch, you're going to get less valid simulations. The simulation sorting priority. So when we get into the actual software, you're going to see a number of simulations. This is simulation number 1 of 10, number 1 of 12. The number 1 simulation will be the one that is most compliant with this sorting priority. So at the top of the list, you see minimize number of tool changes. Well, that's only going to be an issue if I have multiple die sets. So I have one die set here, I have another die set here. There's 7 bends in my part. 3 bends happen here and 4 bends happen over here. But the way we do the part, we do bend 1, bend 2, bend 3, bend 4, bend 5, bend 6, bend 7. So we see that that part has been split over 2 different sets of tools. The software is going to try and keep that most number of bends over here first. So it's going to try to do 1, 2, 3 here and then 4, 5, 6, 7 over here, or 1, 2, 3, 4 here and 5, 6, 7 over here. Minimize the number of times I move between tools. Again, fairly rare issue for that to happen. Then as I move down the list, minimize part flips, minimize part turns. So a flip is either left to right or front to back. that's considered a flip. It depends on what my part looks like. If I've got a basically square piece of steel, then the size of the part, the flips and the turns don't really matter. But if I've got a part that's 6 feet long and 6 inches wide, and I've got 3 bends at this end and 3 bends at this end, I'm probably going to want to make sure that I do all the 3 bends here first, then rotate and do all the bends here second. Again, a lot of that's going to be personal preference. You guys have the ability to set your bend sequences individually, okay? The rest of the stroke length, gaugeable steps, and then steps, not really a huge concern. Mostly it's the flips and turns that really eat up your production time. So the next field down, sequences must have gauge points, show machine housings, and show generate simulations window. So sequences must have gauge points. My machine has a gauge. With that machine having a gauge, I want to make use of that. So generally speaking, I want to have this must have gauge points selected. Machine housings in simulation. So we're going to see a 3D representation of the machine, the tools, the part, everything. If I have a part that goes back into the gauge any kind of distance, the housings could block the view of my part that I might want to be able to see. I don't need to see the housings. Generate simulations window is going to be a little pop-up box in the corner. Some people like it, some people don't care for it. I will show you how that works, and then I'll probably turn it back off again. It's just literally like anytime you load a website, you get a little icon that says loading, loading. That's all that is. And when it goes to the generate sequences process, you're going to see that little window pop up and say, hey, I'm still working. And you're going to see a percentage bar across the top that will tell you, hey, we're still working. When it gets past the center, you'll actually see a percentage for that, but it'll actually show up there. That generate simulations window is in no way actually required. I kind of dig it, but that's just me. We've already talked about the colors. Up on the right side, program generation preferences. Now, program generation, this is whether you're doing offline programming or you are programming at the actual machine. When you go in and hit create new program, you're going to actually see this R-axis default to 50 thousandths of an inch. And what that's indicating is that the front corner of the gauge block is going to be 50 thousandths of an inch above the top of the lower tool. That gives you clearance. If I have to bring the gauges in above the tools, that allows me 50 thou clearance between the top of the die and the bottom of the finger. That's a default value. You can change that if you want. If you do, just be careful with that. We put that 50 thousandths in there for a specific reason. It always gives me some wiggle room if my tool height isn't exact or my gauge isn't perfectly aligned. A, you've got a problem there, but B, it allows me to make sure I'm clear if I have to bring the actual gauge over top of the dies. That can be changed by the operator in the software itself. It doesn't necessarily need to be changed. Our axis offset, we are not messing with. Default forming speed. If I'm bending a lot of widgets, tiny little pieces where the operators are trying to get the machine running as efficiently as possible, that default speed can be increased. I would stay away from that. My recommendation is you leave that forming speed alone. Let the operators make that call at the machine, not in the offline, because me as the offline programmer, I may or may not be paying attention to the fact that I've got a part that sticks 4 or 5 plus feet out the front of the machine. And if that forming speed is too high, we end up turning the machine into a catapult. And that, again, is not going to end well, generally speaking. calculate minimum ram opening. So if I'm using the offline software and I'm creating a program, the machine knows how big the part is behind the dies, okay, whether it's an inch or 5 inches or 10 inches or whatever it is. What it's going to do is going to take that tangential measurement from the bend location out to the end of the part, and it's going to say, hey, that's 4 inches. So when we bend this piece of steel, I need to open the gap between the lower die and the upper die at least 2.5 or whatever the software calculates it to be. This is really good if you're just generically writing programs and your operators just go with whatever you have. If I'm running the machine, that's where I make up a lot of time. If that ram opening is too big and I'm running parts and I have to stand there and watch the ram go up every time I make a part and then watch the ram go up every time I make the next bend, that's eating up a lot of time. So I'm probably going to change that myself at the machine for the purposes of streamlining the speed. Maximum bends between gauge point. Well, right now it's checked for unlimited. So when we say maximum bends between gauge points, if I have a complicated part where I'm making many bends, okay, so you guys can kind of see this part has all kinds of accordion bends. So if I'm trying to make a bend, I don't want my gauge out here, okay, I'm trying to see if I can, there we go, that's a better spot. I don't want to try to gauge out here if I'm trying to bend here. That thing's going to accordion across these other 6, 7 bends, okay? I really don't want that accordion factor in there. So I only want one bend between where my gauge is going to be and where my actual tools are coming in to make the bend. So this would be flat. This would be where I make my next bend. I'm going to gauge here. There's one bend here and then the tools. So I'm going to uncheck that unlimited and I'm going to leave that max bends between gauge point at 1. That gives me one actual bend between where the gauge is going to be hitting the part and where the tools are coming down to make the bend. Okay? Gauging priority, I sincerely doubt any of you have front gauges. We're not going to mess with that. Back gauge finger, again, these settings I'm not going to mess with. Front to back weight ratio, 51%. That indicates that when I create a program, when I generate simulations actually, it's going to try to keep more than half the weight toward the operator. That way the operator has the ability to manage the part without it drooping back into the gauge area. Because if it droops back into the gauge area, I have to sit there and try to hold the part to keep it from falling in. Whereas if I have more than half the weight towards me, I can simply hold the part. I can use my material supports. I can use a table, whatever it is you guys are using for material supports. I like to have the weight where I can handle it. Okay, so it's going to try to put as much weight, over half the weight, toward me unless it just can't. All right, use gauge fingers to support the part. If you are using a stepped finger where you have an edge and you have a step, every chance it gets, it's going to try to put the part on the step instead of trying to gauge against the front of the finger. Okay, so I like using my gauge to support the part because not only does it give me a support, it gives me a gauging point. So I have two points of contact rather than just one, especially if you're doing long bends with light gauge steel. So if you're doing like 18, 20 gauge steel and you're trying to make a bend that's 10, 12 inches long or deep into the machine, it's going to have a tendency to droop down. So then I got to kind of wiggle the part in and set it up or try to have it hit the front corner of that finger. It's not going to be useful. Okay, it's going to be very challenging to use. I like to use the step so I can get both on top of the flat and up against the block. Okay. Tool selection, V tolerance. This is if you're using the software to select tooling. There are V select. There are automatically Let me back that up. There are values in the actual software where it says, okay, you're trying to bend a piece of 1/4 inch steel. So we're going to look at ideally 8T as the ideal V opening. So 1/4 inch times 8 is going to be a 2-inch V. That tool selection V tolerance means 8T is the goal, 6T, 2 down, or 10T, 2 up, is going to be the range that we're going to try to look for. Okay, so if I'm using that 1/4 inch steel, 8T is 2 inches, 6T 1.5 inches, 10T 2.5 inches. So that's going to give me my tool selection criteria between 1.5 inches and 2.5 inches. You can change that to 3, 4T, but again, I'm going to discourage that. All right, flat pattern, extended bend. Don't touch these. These are going to be something you don't want to mess with. I do have customers that have programmers who are very well versed in machine code. You can modify these, but at your own risk. I cannot guarantee anything that's going to happen, good or bad. If you're going to start messing with those things, talk to us first, okay? Do not mess with those. So that is the CAD preferences. We're going to go to CAD preferences continued. There's a couple of things I want to look at here. Workpiece movement control. So calculate the forming speed to limit the speed of the outer edge at the workpiece. So right now it's unchecked. So it doesn't care how big that part is. So if I've got a part sticking 5 feet out the front of the machine and my forming speed is 20 inches a minute, I'm going to get some serious catapult action going on there. So if I check this, and then I'm going to go in here, I'm going to say, well, I certainly don't want 400 inches a minute. Let's take that down to, say, 50. Okay, so if the workpiece is less or more than 12 inches, that's the third value here. If the workpiece is more than 12 inches back into the gauge, it's going to override your forming speed automatically to keep the outer edge less than 50 inches a minute. Now you can make that as high or as low as you want. 50 is decent for me. I could go 20 inches a minute, but then you're going to get some really slow moving machines. Kind of personal preference on that, but again, I'm going to go talk to my operators on the floor and say, hey, with this part, how fast do you usually set the forming speed? And then I can kind of backdoor that a little bit and come in and set the values there, see what it comes out with. Speed change down, speed change up. For those of you that have a light curtain safety device on your machine, I strongly recommend that you go in and you check this value. It should be 1/4 inch. When we first incorporated the laser safe presence sensing devices, there were some issues with that 1/4 inch speed change that caused the laser guard to kind of freak out a little bit. So we went in and we set that default speed change at 3/8, so 0.375. What I find is that that's the default value for all of our machines, whether you have a laser guard or a light curtain. The problem is the light curtain mute point is going to default at 1/4 inch, which is different from the speed change. So the mute point happens at 1/4 inch, but the speed change happens 1/8 inch above that. I have speed change. I have my downstop, which again is in the software. The downstop is happening at 3/8 inch. The speed change is happening at 1/4. So for 1/8 inch, I've got an operator who's used to just running from the downstop. He's having to fight that 1/8 inch difference. So the light guard is active, but the speed is already changed to forming speed, which again is supposed to be safe. So what I want to do is I want to make sure I change that back to 1/4 inch any chance I get. Okay, the newer machines, they don't really need the 3/8 for the laser safe. So even if you have a laser safe, there's still not a necessity to have that at 1/4 inch. Okay, speed change up, we're not messing with. Default return speed, I have had several customers crank that number up simply because my default return speed. This is all just get out of my way. This is the RAM going up, get out of my way. So the higher that number is, the faster the RAM moves up. Okay. Now, if I have a RAM opening of an inch, then that number doesn't matter. It's going to move up for an inch. But if I have a RAM opening of 10 inches or 5 inches or whatever, and that return speed is at 20 inches a minute, that means I'm literally sitting there for 30, 40 seconds watching the RAM go back up at 20 inches a minute. So I have had customers just go in and crank that up. I'm not sure what my default return here is. Oh, I'd have to look at the actual config. A lot of my customers go in and they will crank that up to maximum speed simply because it's more efficient. But that will affect how your operators are handling the material. So again, be cautious when you're doing that. Okay, so that is the CAD preferences continued. The last thing we're going to look at, and then we're going to take a break. The last thing we're going to look at is the options tab. So at the options tab, if I bring this in from the machine, these will be the same things that are turned on at the machine. What you may not have is this bend simulation checkbox checked. So you're going to want to check that. If you have purchased the solid interface, so we're talking the unfolder module, if you've purchased the solid interface, then you're going to want to check the solid interface. But be aware, you can't just check that box and not have the actual bend simulation software and hard lock. If you don't have both of those, checking the solid interface doesn't do you any good, because you're going to try to launch the unfolder and it's going to say, hey, I'm looking for the hard lock, or this isn't installed. So just checking this doesn't magically give you the unfolder module. Okay. Most of the rest of this is going to be overridden by the machine. So I can check anything I want to here. It's not going to matter if it's not turned on at the machine. I take the part out to the machine and some of these are turned off, it will not appear. They just won't magically turn on for you. Okay. If you are in manager or above at the machine, you do have the ability to modify some of your light guard settings. But again, this is only going to be manager or above. All right. Be very cautious about modifying any of these numbers. Anything you change here does change some of the safety profile of your machine. So you're going to want to be real careful about changing any of those. I would talk to my safety guy. I would talk to us if you want to make any of those modifications, unless you know what's going on. But again, be cautious about that. So that's the configuration. Those are the things that matter from an offline programming standpoint. As I said, there are tons of things here that you can go through and pick out each and every time, but they're not really going to affect the way I do offline programming. Okay, so with that, I am done with the configuration. We do have, before we take a break, we do have a couple of poll questions for you. So I'm going to turn it back over to Nikki for the poll questions. And then once we finish with the first poll question, we're going to take a 15-minute break. Okay, so Nikki.
All right, let me launch it up. Okay, so for your first polling question, it's what is your area of expertise regarding your press brake? I'm an engineer, I'm an operator, I'm a manager, I'm a technician, or other. I'll give you guys a few seconds to answer. All right, I'm going to close the response here in 3, 2, 1. All right, I'm going to go ahead and close it. All right, here are the results. So 51% of you said you were an engineer, 13% of you said you were an operator, 18% of you said you were a manager, 4% said a technician, and 13% of you said you were other. All
Okay.
right, back to you, Eric.
Cool. So with majority of you being engineers, that's not surprising. This is what the offline software is designed for, to allow me to pull a part out of whatever design software, Solid Edge, SolidWorks, Pro E, whatever it is you're using, to take those drawings into a DX from a DXF DWG IGES file and bring them directly into the offline software. And then in the offline software, I create a program. That program can go directly out to the machine, and it's going to already have a majority of the programming finished. So that makes sense. And then, of course, managers, we want to know, hey, what are my guys doing with the software? That's always a big concern. And operators, I get plenty of operators who are both operators and design guys. You know, just because, you know, I'm running the machine doesn't mean I can't lay out parts too. So I get a lot of my operators are doing their own programming from a DXF even. Now, I don't know how much, you know, it's not often that they can get in and actually modify the DXF, but they will take the DXF from engineering and bring that directly in at the machine or in offline, but a lot of times it's at the machine. And I can, as an operator, I can create my own program knowing, hey, I know when I make this, I don't bend it this way, I bend it this way and then this way. So it's easier for me to make that call at the machine. So with that, it's 1:53, 54. We're gonna go ahead and take a 15-minute break. Now, in that break time, at 2:05, so 10 minutes from now, I'm actually going to come back and I'm going to start answering. We've got a whole bunch of questions here. I'm going to spend 5 minutes doing a Q&A on what I have here, and then we will also do another 5 or 10 minutes at the end of this presentation for questions as well. Okay, so Nikki.
All right.
Okay, everybody, we got 5 minutes left on the break. I'm going to go ahead and start with some Q&A. So looking down the list of questions, there were several that were about the handout. Looks like we got that sorted out. A couple of these I'm going to have to answer offline because I've got a handout I probably should have had available for this. I can send that out if you want to request how to import or how to get the machine configuration off the machine. Again, if you're at the machine and you're logged in as operator, there's a hidden system folder. So D press brake system. It's hidden on purpose because there's things in there that can affect how your machine operates. But if you're in D, I said that wrong, that D press brake folder, there will be a config file in that hidden folder. But if you just go to search, either if you're like Windows 8, Windows 10, and you're in Windows Explorer, then you can actually just click, once you're in the D press brake folder, you can actually just go to the search bar in the upper right-hand corner, and it gives you the option to do a search, literally .cfg. That's all you have to search for, and it'll bring up every single configuration file in your software. Or in that folder. So what you're going to be looking for is your machine's serial number. If you guys were looking when I went into the configuration general tab, I am basically running configuration number 000001. So yours is going to be your machine. If you look at the front right side of your machine, at the top of the bed, at the far right end of the bed, you'll see your machine serial number. You can also go into your, again, maintenance configuration general, and it'll show you the machine serial number at the top of the general tab. You want to copy that. So you're either going to be on the network and you're going to copy it to a network folder, or you're going to have a flash drive and you just copy it onto a flash drive. That way it is available. Then you take that to your computer and then import maintenance configuration general, configuration utilities, and AFPC import, I want to say. And then you need to know where that folder is. You grab that wherever the root folder is, where it is, where you have the file stored. So if I just put a flash drive in, plug it in, and put it right at the root of the flash drive, I plug the flash drive in and then just say, what drive, drive E, drive G, whatever that USB folder is, USB drive is, point it at that folder, click OK, and it'll grab any configurations on there. So if you've got 10 machines and you want to copy all of the configurations, copy them one by one onto that same flash drive. You hit the import feature, it'll import all 10 of those. Then you have to remember to go to the drop down and say, hey, this is machine number 1, this is machine number 2, this is machine number 3. It'll bring in all of the actual configurations for that layout. So the version of my machine is 3.8.1. If I save programs with the new version, it will still work, but you're likely to get unknown errors. I can use 5.0.4.5 to make programs for well, I have to put a caveat on there. 3.8 is, as far as software revisions go, 3.8 is slightly ancient. I want to say it'll work. I can't guarantee you won't run into glitches using that newer version of the software. Try it and see. All you can do is see. We do have, you can request downloads of older versions under the existing users. So the same link that Nikki presented in the questions field, where you can go to the products, oh no, that's the download for the thing. If you go to e-ci.com, then you go to the software section, look for press brakes. There is a link in there where you can download The newer versions, or I'm sorry, older versions, I'd have to look and see if you can get back as far as 3.8. But if that's the case, you can download the older version, install that, and just write programs on the 3.8. So you'll be nearly identical to what you're running at the machine. That way you're not going to have machine version issues. Okay. Why not change the pinch point dimension to 1/4 of an inch rather than 1 inch as default? The 1 inch I think was picked by our safety department. That you'd have to ask them why they would use an inch. I think it was just generically the width of the average human digit is more than 1/4, less than 1 inch average. So if it's at an inch and I bring a part up and I'm holding it like a knucklehead and I've got that part sitting in my hands like this, where I should never be holding a part, right? If I'm making an upward bend, I should not have my hand over the part like this. But if I do that and the part comes up and I have that 1 inch default, then I did not, there we go. Okay, so I didn't lose my actual finger or fingers in that instance. So that's probably why that's at 1 inch, 1/4 inch. I mean, you can set it to anything you feel is safe. Okay. Don't you have to hit apply? Not particularly. The apply function for probably the last, I don't know, 10, 15 years, you may, in our software at least, when you make a change and then you hit OK, the OK function automatically goes in and applies those changes. So you don't necessarily have to hit apply. If it makes you feel warm and fuzzy inside to hit apply, no problem. But the requirement to hit that, no, you don't need to hit that. Currently, then simulation press brake, can only see the part. So there's a question about when I'm in the offline software. I write a program, I can see the actual tools, I can see the gauge fingers, I can see the ram, the bed, the filler block, I can see everything. But then I get to the machine, and when I get to the machine, all I have is the gauge blocks and the part. So at the machine, you do not have the bend simulation feature enabled. That is a paid feature to have turned on at the machine. If you purchased the offline software separate from your machine, then it wasn't turned on at the machine. That's something you would have to talk to either your serviceman or to parts about, to see about getting that enabled at your machine. That's not something I can really address. It's a purchasing issue, but that is why you're not seeing the tools, the ram, the bed, the filler block, because the bend simulation function has not been turned on at the machine. All you have is the basic CAD feature. Okay. Is there a parameter? Okay, so is there a parameter setting in the software that will calculate for material shrinkage or stretch or bend allowance? Now, bending plastics is a whole nother universe of bending, because plastic doesn't necessarily follow the same physics as metal. A lot more spring back. A lot of my customers that are bending PVC or Lexan, they will actually heat their material up to get the material to be more pliable, and they will actually thermally set the bend. They'll actually have the part sitting at that bend and letting it cool while it's held in the tools. That way, when it cools down, you experience less spring back. Plastic, I don't think this is going to work for you, but there is a gauge allowance function in our software. If you look at my screen here, you can see to the right side, I have a gauge allowance window. Now, currently it's set to 0, and I don't have a material type. I don't have a material thickness. Well, I have a thickness. I don't have tools selected. the tool selection will be a huge part of that gauge allowance calculation. So as you can see right now, I don't have gauge allowance selected, so I have gauge allowance. I don't have tools selected, so it's not going to give me an accurate calculated gauge allowance. What you can do, and since we're talking plastic here, it's going to be more art than science. The stretch out or shrinkage or whatever you're experiencing, you're going to have to bend apart. You're going to have to see if you can get a consistent value for that stretch or shrinkage. And then whatever that number is, I'm going to change this gauge allowance to allow for the stretch. So a positive number means that my part is shrinking and I need to move the gauge further back. A negative number, like you see on the screen right now here, so that negative 75 thousandths, that means if I set a flange dimension of 2 inches, the gauge is going to come up to the edge of that flange, and then it's going to come in 75 thousandths of an inch to allow for my part to stretch by 75 thou. So I can go in and I can say, hey, I want a 2-inch flange, and then in this case, the software is going to adjust for both what the angle is and what the V opening on the lower die, and in this case, you can see I have a bend radius of 0.156 down there in the lower left corner, but that's because I haven't selected tooling. The machine has no reference for what it is I'm going to be doing. That value with plastic, I'm going to be guessing at that because I don't have a lot of experience with plastic, but I'm going to be guessing at that. But again, if the part is too long, if it's stretching too far, you make a negative adjustment however far. So I bend this piece, I want 3-inch flange, and I bend it and I measure and it's 3.05. I would make a 50 thou negative adjustment to that gauge allowance, and it brings the gauge in 50 thou. So then I bend the next piece, it should be pretty close to 3 inches. But again, we're talking plastic. I can't give you a hard and fast rule there. Generally speaking, the plastic is going to be its own monster. Okay. But with metal, with the stainless, with mild steel, with any of your various material types, okay, I have a whole drop down selection here of all the most of the standard common types of steel: high strength, low alloy, stainless, copper, aluminum. Those are all there. So if I select my materials, let's say I'm bending stainless steel and I'm bending 16 gauge, so I'm going to use a 1/2 inch V. Now, why 1/2 inch? Well, we're talking 8 times the material thickness, so 8 times 0.06 is 0.480. So I would be looking for a lower tool V opening of a 1/2 inch. So that's what I have here. This is a 75-degree 1/2 inch V opening die. When I select that tool, and then I'm going to select an upper tool, so I have a 75 lower, I'm going to use a 75 upper, put that in. Now you will see back here on the gauge allowance, now I have a 78 thou bend radius and I have a 58 thou gauge allowance. So I expect that piece of 16 gauge steel to stretch slightly less than material thickness. So again, I'm going to say the 3-inch flange, the gauge is going to actually move into, before the bend, the gauge is going to set at 2.942. And then when I bend it, it'll stretch out to 3 inches and give me plus or minus 3 or 4 thou, depending on the alignment of your gauge. I should be less than 5. I will say that. So if you're doing steel, this thing is a wonderful thing. If you're doing other materials, I can't really speak to that. Yeah, shrinkage, bend, plastic. Yeah, that's right. Oh, the last question, and then I'm going to get back to the software. You have an operating system of Windows XP. So because your machine has Windows XP, you probably can't network it, because no network administrator out there they're going to lose their mind if you try to tell them they want to put an XP machine on the network. Yes, you can update. you can upgrade, but again, that's going to be a question for the sales, or actually for parts. Get your machine serial number, call up our parts department and say, hey, I've got serial number 5555555, whatever it is. I need to see if I can update. They will pull your machine configuration, your machine as it was sold, and they'll say, yes, this can be upgraded, and generally speaking, this is how much it costs. There's a software update, there's a possible motherboard update, there are hard drive updates, there are all kinds of that. All that stuff can be updated, but sometimes it's a can of worms. If you update A, then the version of A is no longer compatible with B. And if I update B, then B is now no longer compatible with C, D, E, and F. And now I got to update C, D, E, and F. I can't speak to that overly. I just know that I've done my share of upgrades, and sometimes it can get expensive. But as far as pricing goes, you'd have to talk to parts. Okay? And that is all of our questions right now. So I'm going to get back in to the actual software. And again, if you have more questions or questions based off of what I just said, feel free to throw them in there. And we're going to have about 10 minutes at the end of this to also do questions. All right, so programming. Now, if I go up here and I just hit the new button, okay, it's just going to go into a new text mode program. But if I go up here to the file menu, so again, I've got new program, but now I have this new CAD part. So if I click on new CAD part, it's going to bring up another window. And there's three options here: draw cross section, draw as a flat pattern, or convert from a drawing file. Now, just real quick and easy, I'm going to do the cross section. I'll explain the flat pattern, but I'm going to spend the most time in converting drawings. So draw as a cross section. Basically, what you have here is you have a Etch-a-Sketch. If y'all can remember the old kid's toy where you had the two knobs, where you turn the one knob and it goes up and down, you turn the other knob and it goes back and forth. That's what I have on the screen here. Now, generally speaking, the approach that we take for writing a program is we start at the top left and we work our way to the right. And then we work from the top down. So in the upper left corner, I have same thing I had on the actual software for the text mode program. I have the type of steel. So again, let's say I'm bending stainless steel. Now, material thickness. When I click on material thickness, you will notice I have these presets over here for all the gauges, 20 gauge, 18, 16, all the way down to 10 gauge. These buttons are not your friend. Okay, generally speaking, if I know that I'm making a 16 gauge part, I can go in and say, hey, it's 16 gauge. But the problem is when we get our steel from the, the high quality, highest possible grade steel supplier that I know you're all using, just because it says that it's 16 gauge doesn't mean that it's 0.06. Can I write my programs at 0.06? Sure. But the farther off that the physical steel is that the operator is bending, the more your offline program is going to be off of the actual reality. So what I normally recommend to my engineers, to my programmers, is I say, hey, spend 10 minutes, go down to the shop floor, grab half a dozen different sample pieces from different runs, get your calipers out, actually measure down to the thousandths, I'd say half a thou, average out all those measurements, measure 10 pieces of steel, 10 pieces of 16 gauge, and then average the thickness of all those 10 pieces, and then write that down. Maybe even go into your settings and change the default from 0.06. All the steel that I measured is averaging out to 0.057. Well, I'm going to go in and I'm going to set my default to 0.057. That gets me just closer, generally speaking, to the target zone, and you're going to get better results. Okay, but in this case, I'm bending 16 gauge stainless. I measured the steel, and my steel actually came in at 0.057. Okay. Now, K-factor, there's an entire presentation we could go into just on K-factor. I'm not digging too deep into that now. I will tell you that there are industry standards that our software uses. And just a quick shout out to the Fabricator magazine. If any of you are familiar with the Fabricator, there's an article, a column in there every month on bending basics. And the guy who writes that is, he's probably forgotten more than I've ever known about bending metal. I see a lot of good information in there. Our default settings for Auto K match what their general recommendations are. So I would just leave that at Auto K unless you have a reason to change that. Now, if we're importing a drawing, depending on the type, it will override that Auto K. If you have a custom K factor, it'll override that. If not, then it will just make its best guess as to what you're trying to do. Now, I'm just going to do a simple hat channel. Okay, I'm just going to draw this out. So you'll notice none of these are here. None of these can be interacted with. I'm simply going to go in here and I'm just going to draw a hat channel. Okay. Now I'm not taking a lot of time to try to make it look pretty because I'm going to fix that in the next scene, in the next screen. Okay. So right now I've got 5 lengths of flange and I've got 4 bends. The only thing that I care about right now is this bend length. I'm going to be working off a blank that's 8 by 12. So it's 8 wide by 12 long. I'm going to say my bend length is 8 inches. Okay. If you're dealing with a rectangular piece of steel, that's what it'll be. So from there, I'm not going to mess with any of the rest of this stuff. I'm simply going to click OK. And there is my hat channel. Now remember, I changed my color settings so that the bottom of the part was green and the top of the part is gray. So I know that this bend is a down 90. Okay, because it's showing up as a negative 90 and I click next, you'll see that's a positive 90. So if I get that wrong, you'll notice if I were to go in here and say, oh, positive 90, it flips the whole part over. So you just have to make sure you keep your up-down orientation. So again, mild or stainless steel, 16 gauge, and this bend, 90-degree angle. The next bend, oh, also 90. The third bend, oh, 85. So I'm gonna go in here, I'm gonna say 90. I could go and hit all bends, but then it's gonna flip the up bends downward. So I'm just gonna do this one by one, enter. And then my last step, oh, I got 3 out of the 4 right. So there's my 3 bends. Now, bend radius. And if any of you watched the previous webinar with Jim went into this bend radius function quite a bit. I'm going to put out just what we use. So we calculate bend radius. Our formula is going to be the opening of the V times 0.156 or 5/32. And again, there's a whole lot bigger explanation on that I'm not going to go into in this presentation. Just understand we're going to be using a 5/32 value to calculate bend radius. Now, the V that I'm actually going to be using for this is a Wilson lower die 50022 is the tool number. It's got a 0.404 V opening. So in order to calculate this, I'm going to go 0.404, my V opening on that die that I measured, times 5/32 or 0.156 equals, so that's my bend radius. And you'll notice that's a 1/16 of an inch. That's why that V opening is the way it is. It gives me a 1/16 bend radius. Now, I'm going to be bending all 4 of these angles on the same V opening. So I'm going to set all bends, I'm going to hit enter. This will physically change the length of your part. I get a lot of my engineers will tell you bend radius is simply material thickness, not if you're using overly wide or overly narrow V openings. If you're using a very narrow V, that bend radius is going to shrink. If you're using an overly wide V, that bend radius is going to grow. Okay, all of that is determined by the lower die when you're air bending. Okay, and again, I'm not going to rehash what we went over in the previous webinar. So 90-degree downward bend with a 1/16 bend radius. So there's my 4 bends. If you watch as I go through there's my 4 bends. So again, just a generic part. I'm going to have a 1 inch, a 2 inch, a 1 inch, and a 2 inch, and I'm not going to have a dimension here. So I'm going to go down here to this edit flanges. I'm going to flatten this part out. So now you can see there's my 5 flanges that I drew earlier. So flange A, and now in the color scheme here, I've got a vertical blue arrow and I've got a horizontal red arrow. Again, you can change your color preferences on these to suit whatever you personally need. My flange dimension here is a 1 inch. My flange dimension here is going to be 2 inches. I'm going to make this 6, and then these are just numbers I'm pulling out of my head. These are not actual values that I have written down anywhere. And 1. So there's my layout. So if you notice in the upper right corner here, I've got a flat of 11.554 by 8 inches. Theoretically, when I finish this part completely, it's going to be 12 with all 4 of the bends stretched out, 1 inch, 2 inch, 2 inch, 1 inch. That's 6 plus my base plate of 6 inches. That's going to be a 12-inch overall. But my cut size with all my bend deductions, my bend allowances, outside setbacks, whatever you want to call it, with all of those deductions in place, there's my 11.5 inches that will stretch out to 12. Okay, so I'm going to close this out. I'm going to fold it back up, and there is my part. Now, when I was going through the configuration, I mentioned rotation angle, 15 degrees. I can rotate using these angles, but I find it's just way easier to grab and move like so. All right, so now that's there. I'm going to move, I'm done with editing the part. From here, I'm going to move to my simulation setup. And again, left to right, top to bottom. From the very top, I'm going to, let me back up. I'm going to flatten this out again. You'll notice that I have question marks. Each of my bends is indicated as a question mark because I'm going to let the software figure out how to bend the part. It's going to do that for me. I can absolutely go in here and I can say bend number 1, bend number 2, bend number 3, bend number 4. But I'm going to let the software do its thing. Let it figure it out for me. Okay, so fold this back up, and I'm going to go back to the simulation setup. Okay, so left to right, bend sequence question mark. Again, the software is figuring this out for me. Finger selection. So in this case, I have a 5-axis back gauge on this machine. That 5-axis gauge has 4 finger placements. I have the upper carriage on the left, lower carriage on the left, upper carriage on the right, lower carriage on the right. If you're using a different gauge type, these will change. These will vary. If you're using a 6-axis gauge, you're not going to have this here. You're only going to have these 2. You will have this, and I don't believe you have the selection preference because you don't have an upper carriage and a lower carriage. For right now, my fingers are in the upper carriage on my 5-axis gauge. That's where they're going to be. This is a one and done setting. Once I set this, I do not have to come back and change that. It can literally just be there forever. Unless I physically change the actual location of the fingers at the machine, then I might want to change it. Okay. From there, I'm going to my tool selection. So earlier I talked about my tool library. So the tool library is broken down into 2 separate sections. I've got my tool inventory and I have my tool layout. So this is an inventory of all the tools I have available. I am starting in the lower tools. And as I mentioned, the V opening I'm using is 0.404, since this is a standard Wilson 30-degree lower die. I also have the 75-degree dies, but that's a different V opening. So if I were going to use the 75-degree dies, I'd want to go back and recalculate my gauge allowance for each of those settings. So I'm going to use this 50022. I can either double click on it, or I can highlight and I can hit add selected tool to layout. And I will point out, you see this red line here? No good. You don't want those tools interfering with each other. So I'm deleting that lower die. There's my 404 V opening lower. How did I pick the 404? Again, we have the V opening is my material thickness multiplied by a factor of 8, which is our recommended V opening for these tools. 480 was my actual calculated, actually be like 456 for my 0.057. I'm not going to get too bogged down into those numbers. So I've got my 404 lower. Now I'm going to go back to my upper. So I'm using a 30-degree lower. I'm going to select a 30-degree upper. Now in this case, I've got 3 options, but that's a 75-degree upper. I don't want to try to use a 75-degree upper on a 30-degree lower, because you're looking at, 5 pounds of crap in a 3-pound bag. 75 upper is not going to work well with a 30-degree lower. Now, I could reverse that and be fine. I can use a 30 upper on a 75 lower, on an 85 lower, whatever you want to do there. But the upper has to be smaller than the lower, narrower than the lower. So I've got 2 options here, the 50045, which is a straight V punch, and a 50209, which is a gooseneck. Because I'm bending this hat channel, I'm going to use the gooseneck, just because. There's no critical reason why, but if I did have 2 up bends coming in next to each other where it might interfere, then the gooseneck is absolutely required to keep it from back bending against the back of the punch. So there's my upper tool, there's my lower tool. 30 upper, 30 lower. I am done with my tool selection. All right, so then down here I have my generate simulations. Okay, now you can change your mode here, but graphics mode is not going to be overly useful if you're trying to do bottom bending, tonnage mode bending. Position mode, yeah, but if I can get away with angle mode, I'm going to use angle mode. And again, I'm not going to dig too deep into that because we've covered that in the previous webinar. I'm just going to come down here. I'm going to hit generate simulations. Now, when I hit this, you're going to see a little window pop up here, and it's going to start flashing colors and stuff, and it's going to show that it's trying to do the simulation. And there it is. That's that generate simulations window. If you don't like that, you can go in maintenance configuration, CAD preferences. You can turn that off, and now generate simulations, the window didn't pop up. Now down here at the bottom left corner, you see I have valid simulations 12, meaning the software came out and said, there are 12 ways of bending this. There are not 12 ways of bending this. The machine is being overly thorough. There's like 4 maybe that you can do for this, but the machine says there's 12. So now that I've generated simulations, I'm gonna go down here to my simulation view, and there is my machine. Now you'll notice I turned off the housings so you can't see the machine housings, okay? There's my back gauge, there's my part, there's my upper tool, there's my lower tool. This is what you miss if you don't have the bend simulation enabled here or at the machine. You will not see the upper, you will not see the lower, you will not see the filler block. You will literally just see the part and the gauge, okay? And again, that's a question you're gonna have to take up with parts as far as getting it enabled at the machine, okay? So there's the upper tool, there's the lower tool, there's the part, there's the gauge. Now, right now, what I'm looking at is called the isometric view. Most of you, at least half of you are engineers, so you're gonna understand the ISO view. I'm not a huge fan of the ISO view. I like the side view so I can actually see where the part is on the die, where the part is on the gauge. Okay, now I'm on simulation number 1 of 12, bend number 1 of 4. So this is the first simulation. I've got 11 more, but here's the thing. If I find that this one works, I'm not even gonna mess with the rest of those. I'm gonna stick with the one that works best. So step 1, simulation 1, okay. That works. I'm not going to use that gauge point, but I'm not messing with gauge points until I get the right simulation. So simulation step number 1, step number 2. Well, okay, so the machine had me rotate the part 180 degrees. If it's a small part, maybe that works fine. But me, as the operator on this, I don't want to be rotating my part end to end. I want to get all my bending done down here first. I'm going to bend, I'm going to flip, and then I'm going to bend. Then I'm going to rotate the part around and make the bends on the other side. So step 2, I disagree with. So I'm going to stay on step 2, and then I'm going to go look at simulation number 2. Well, that didn't change. 3 didn't change. 4 didn't change. 5, oh, okay. Well, 5 changed. But I'm not a real big fan of that. I don't really like that step that way. So I'm not going to do that either. So step 6, oh wait, no, my bad. Simulation 6, 7, nope, 8, 9. So simulation number 9, step 1, bend up, flip, bend down. I like that simulation. So then step 3, rotate the part end to end. Step 4, flip that over. Simulation number 9 is the one that I'm going to choose. Okay, so now I'm going to go back to step 1. And as I mentioned, I don't like that gauge point. So I'm going to go down here at the bottom of the screen. Okay, now you can manually change any of these numbers, but I'm going to go down here to the bottom of the screen and I have my gauge point selections. Okay. And if I hover there, nope, okay, no alt tag there. So this is gauge point 1. Since I'm using a step finger, gauge point 1 is indicating the edge of the finger itself. I'm going to go to gauge point 2, okay, and you'll notice both fingers came down and underneath. So that not only gives me a gauge point, but it gives me a rest for where that part is going to be. So I can gauge against the block, and then I can rest it on the actual step of the finger. So that's good. I like that. So now I'm going to go to step 2. Now you'll notice I'm back on the edge of the finger, but you will also notice I'm a 1/4 of an inch down. If that 90 right there is not a true dead 90, the farther down those fingers go, the more likely I am for this dimension to be affected by this over or under bend on this angle. So I don't want to be right on that flat. So I'm actually going to bring that up to about a 0.15 negative. And you can see, so now I'm right at the corner of the bend and I'm on the flat. I'm not completely on the flat and I'm not in the radius. I'm at the intersection between where the radius starts and where the flat begins. That's where I want to be. Okay. Now, you also notice if you've ever run a brake, what's going to happen here if I begin to bend this? Well, that part's going to come up, it's going to hit my gauge. The software will automatically put a clamp and retract on this step so that you have the gauge getting out of the way. So it's automatically in there, you don't have to worry about that. Now on to step 3, same as I did on step 1, go to the step here. Step 4, same as I did on step 2, I'm going to bring that up to 0.15 negative. Okay. Now, a lot of this is going to be personal preference. If you want it down on the flat, leave it down on the flat. If you want to bring it up higher, bring it up higher. I like where that is. That's just me. Okay. So going back and looking at the ISO view, if you want, again, you can see where that sits for all 4 steps. Now you also may notice the gap between the two tools change every time. And the gap is changing because, again, automatically calculate minimum ram opening between steps. That was another configuration setting in the software. So it's automatically saying, this is going to bend upwards. I need to have this much to clear it. This is going to bend downwards. I need to have this much to clear it. Okay. So there's my 4 steps. Now you will notice from here, I can't actually start my software. Because all we've done here is created a part file. I actually have to go down here and I have to hit create program. Now, do I want to save changes to part file? So everything we've done to lay out this part is a part file. It's literally just a graphic representation of the part. If I have to make any changes to this, change the sequence, change the flange dimensions, change the tools, whatever it is, if I have to come back and make any changes to this, I have to have this part file. If I don't have the part file, I have to start all over again. So I am going to want to save this. I'm going to say yes. And then in my parts folder, it says untitled. Well, untitled doesn't tell me anything. So I'm going to say, well, if this is a part that you have, if you have a drawing number, if you have a name of the part, if it's the left-handed widget hanger, then name it left-handed widget hanger. If it's a part number, then type in the part number. I'm going to say this is a hat channel. I hit enter. Now you'll notice up here at the top, it says hat channel. That got it from the name of the part. So I go down here to my spreadsheet. What I want to point out is, remember I said that on steps 2 and 4, where the part is going to run into the gauge, it automatically put a clamp stop and it put in a retract distance of 1.2 inches for each of those steps. Automatic. Anytime you have vertical contact with the gauge, it's going to automatically pull the gauge back. Okay, so again, that's just a nifty feature. This is now ready to be saved, which you do have to hit save. Okay, save it onto your, if you're on the network, you can save it on the network. If you're on your local PC, save it on the local PC. If you're on a flash drive, you're going to walk it out to the actual machine, save it on a flash drive. Okay, I've just got a program location, D press brake programs. I'm going to save it there. Okay, now you can take that and transport it to the machine however you want to transport that to the machine. So that's drawing out a generic part. So I'm going to go back in here. I'm going to go new CAD part, and it's going to bring this up again. Now, the only difference between cross section and flat pattern is I have the ability to set my dimensions individually. So the previous part, I'm going to do the exact same dimensions. So 1 inch, 2 inch with a 90 downward, and then I had a 6 inch here with a 90 upwards. Then I've got another 2 inch with a 90 upwards, and then I've got my last bend is 1 inch with the 90 downward. Now, the only advantage to me of the flat pattern is it lets me make boxes. It's way easier to make boxes this way than it is to do it with a cross section. So I hit OK. Oh, those went the wrong way. Okay, so literally I've got a pan. Okay, I've got a pan with tabs on it. That's the only real advantage of the flat pattern. From here, you can go through the same way you did with the setup. You just now have to be worried about clearances between the sides on the last 2 bends. Like with any pan, you have tool clearances. Okay, so that's that. Now, the one thing you're probably going to be using more than anything else is going to be this convert drawing file. Now, since this is the basic, since this is the bend simulation and not the unfolder, we only have 3 options here: convert drawing file from a DXF, a DWG, or an IGES file. It's been my experience that most of the time your DXFs and DWGs are going to be more reliable. The IGES files, the most heartache I get, the most heartburn I get is from customers sending me IGES files, just because there's no good standard for IGES files. If you can get it in, get it to work, more power to you. But for the most part, I try to stick to DXFs and DWGs. So I have a couple that I set aside. Okay, now down here, I'm going to do all drawing files. So here it is. I've got DXFs, I've got DWGs, and I've got IGES files. So I'm going to start off with the DXF, and there it is. Actually, I'm going to start off with the simple DXF. So there it is. So 10 by 13.5. I do have the preview part option down here, which can be very useful when I'm trying to figure out which of these do I actually want to open. I actually have the ability to preview it before. Fair warning, if your part has issues, whatever they might be, if you've got a part that has issues and you try to preview it, there's a decent chance when you highlight that part and the preview is turned on, you might crash the software because it's trying to model the part and the model itself has issues. So it's trying to render this model and it's going, I don't have all this information, I'm done. You'll see it, an AF master has crashed. What you're going to want to do is, I would go back and look at that part a little closer in my design software, in my SolidWorks. Wow, my brain just went blank. Whatever my design software is, I'm going to go back there and I'm going to look at that first, or I can turn off the preview, select the drawing. You just won't be able to see it before you open it. Okay. But I'm just saying that preview part can cause issues. So I click open, and there is my flat pattern. This is the same part that I had before, 2 up, 2 down, okay? The first screen, turn off unnecessary entities by clicking on them or by turning off entire layers. Now, this is a very simple, flat layout, so I don't necessarily have to turn anything off. Some of these drawings get really complicated where I could have 10 layers and I could have the full architectural drawing with the text blocks and the ISO view, the flat view, the side view, the top view. All of that stuff is completely unnecessary. So I'm not going to mess with that. But again, this is just a clean, simple drawing. So I'm not turning anything off here. If it's a scaled drawing, first off, get yourself a 1-to-1 scale. But if I have a 1-to-something scale, let's say it's a 1-to-4 scale, then I would put in here my scale is 1-to-4, and that will drastically change the size of my part. I could go even that far if it's a 2-to-1 scale instead of a 1-to-2 scale. Okay, but this is a 1-to-1 scale. I'm leaving that alone. You need to know if it's in English or metric. If it's an English drawing with metric dimensions, then you need to fix yourself and sort that out. But if it's a metric scale drawing, you need to have that in there. But again, that can really mess up your settings. So I'm sticking with English because that's what we use. I'm going to go click next. Now, specify the bend lines. We have to tell the software what the bend lines are going to be. So right now I have 3 options. It does not have bend lines, single line at the center, or 2 lines separated by a bend allowance. Well, these are single lines. So I'm going to say single line. I'm going to click on the first angle, and that is going to be a down 90, and I'm going to be using that 0.404 V opening times 530 seconds, or the 0.156 equals, there's my 063 radius. Okay, now I'm going to do my other down 90 because it remembered what my previous one was. Then I'm going to come in here and I'm going to do my 2 up 90s like so. So again, my 2 ups, my 2 downs, this will be the same as what I did with the draw cross section, but it's laid out flat. I click finish. What's it asking me? Okay, I'm bending stainless steel. It's 057 material. I'm using an auto K factor. If you have a custom K factor, figure out why you're using custom K factors, because they're not necessarily necessary. Oh, that was redundant. They're not always necessary to be custom. You can use our standards, but your layouts are going to be affected by every one of these factors. Now, if I'm using a custom K, I can turn this off, and then I can come in here and I can say, actually, I'm using a 0.368 K factor. That will change your blank size. That'll change every one of your dimensions. Well, it won't change the dimensions. It'll change the stretch out for each of those dimensions. So you need to make sure if you're using a custom K, A, why am I using a custom K? And B, what is it? If not, auto K, let us do the work for you. So I click OK, and there it is. And now we're back to where we were with the actual layout drawing, okay? Now, you'll notice here, all of the values have already been filled in from the drawing, but now I don't have the ability to edit my flange dimensions. I flatten this out. I cannot edit my flange dimensions because it was a drawing. If I wanted to change the dimensions, I have to go back to the DXF, change the values at the DXF, okay? Fold it back up, same thing as before. I'm gonna use the same tools, the 50209, nope. And the 50022, click OK, generate simulations, and it gave me the exact same 12 that I had before, okay? So that was a DXF, all right? I've got a couple others to deal with here, no, convert drawing, all right? So then I've got this, here's an IGES, and you'll notice down here when I click on the IGES, it actually has the ability to rotate around, okay? Now the nifty thing about the IGES is it's got, the really cool thing about this, is it's got all the dimensions in it already, okay? Click open, I've only got one layer, okay? And it already has all of the radius information in there. It's got my bend allowances already in there. This does have a thickness dimension, so I do have to make sure I keep that checked. And then I simply hit finish, and it says, okay, there's your part, okay? Similar to what we did, except this is well, it's the same material, but it's got a wider radius for whatever reason. We would be using that wider radius. So the IGES files are certainly cool, but again, I've had the most heartburn with IGES files. I've got about a 50% success rate with those IGES files. You start getting issues with those IGES files, go back to your solid model, see if you can export to a sheet metal flat, and then bring in the sheet metal flat as a DXF or a DWG. Okay, those are just generally my recommendations. Last one, let's look at something a little more complicated here. So I've got this same drawing, except I've got a window cut into one of those bends. Now, anytime you have a window cut into your bend lines, you're gonna have to indicate that these two lines are collinear. Okay, so again, I'm not turning anything off. Going to the next, I'm gonna specify my bend lines. This is the same as what I was doing before, except now, because I've got that split, I have to indicate on both sides of the bend line, or on both sides of the feature. And again, these are negative. And let's say I make a mistake and I leave that positive. Okay, so that's now going the wrong direction. I can still fix it in the actual layout. So there's all that, okay. So you can see there that my dimension over here is my angle over here is wrong. I can literally just go in and say, yeah, it's good there. But now I have this window and it's indicating two separate bend lines. So when I go to my setup, there's a really good chance that I'm gonna have to go in here and I'm gonna have to indicate these lines individually. So my sequence, actually I'm gonna flatten this out. My sequence here, I'm gonna go 1, 2, 3, and 4. Now the only one I really care about having to indicate is this one here. And you'll notice it kind of picked up that other line also. So I'm gonna go in here, I'm gonna say, this is bend number 4, and this is bend number 4, because it recognized that those are collinear, but I can't always depend on it to realize that those are collinear. So that's the only one I'm gonna mess with. I'm still gonna let it sort out the other 3 bends. So again, simulation setup, 022, 209, and generate simulations. Now you'll see I only have 6 valid simulations because I limited its ability to indicate off these, or to calculate what that sequence is going to be. So again, 1, 2, and it rotated around again. I don't want it to rotate, so I'm going to leave this here. Oh, there it is. So simulation number 5, side view. So simulation 1, 2, 3, and 4. There's my simulation. All right. Now we're coming up on the 2-hour mark here. I've got about another 10 minutes to go over. So if you'll bear with me for one more part, because this is what I really get some heartburn on, is when somebody sends me a file that they didn't take time to clean up. So I've got this part here, and I've just called it mess because this drawing is a mess. So I open this up, and again, there's only a single layer. So there it is. Now, when I go to designate my bend lines, again, 90 degrees, 90 degrees, 90 degrees, 90 degrees, and then 90 degrees, 90 degrees, and then these two go the other way. And uh-oh, what do I have here? What do I have here? Uh-oh, I got a bunch of broken bend lines, don't I? So this is one that a customer sent to me, and I had to go in and start looking at this because when I tried to lay this out, okay, they're broken bend lines. So, all right, so this one was up 90. So up 90, 90, 90, 90. This was a down 90. So down 90, down 90. Oh, one more over here. This was an up. That needs to be up. And then, oh, I missed this little tab over here. It's a down 90. And there it is. Now, when I click OK here, I'm going to get a message that says, hey, this sucks. Could not locate flanges from geometry. Check for connection between line segments. Or I might get an open geometry error message. So now what I have to do is I have to put on my Sherlock hat, and I have to go in here and I have to start looking at things. So the first thing I'm going to look at here is the fact, what? No, maybe that's not this one. No, not this one. No, I picked a poor example. In some of these instances, the bend lines, sorry about that. The bend lines don't actually connect, or in this case, the line actually intersects the radius. Now it's going to call me a liar. This might be the one that I cleaned up, and I might have just grabbed the wrong one. No. I know this one here. My apologies for not checking this ahead of time. Oh, you know what? Hang on. No, that one. That's open. There we go. So now you can actually see here that when they sent it to me, there was a huge gap in the bend lines, okay? And when I start looking at these circles, they don't connect here either, okay? Those have to land, all right? And then when I look down here, no, it was one of these that intersected, and I might not be picking the right one. But in several cases, the actual bend lines intersected with a cut line. You cannot have lines that intersect each other. The lines have to land on the radius or at the actual side, okay? So I had to send this back and say, hey, you need to go over these again and clean all this up because those have to land. They cannot intersect. Okay, so that is a majority of what we cover in the classroom portion of our operator class as far as BEN simulation goes, and the BEN simulation software itself. We do have one more poll question, and I did not see any additional questions pop up in the questions section. So with that, I will call it a day on that. We will do the poll question, and then if you do have any other questions, feel free to get in contact with us. The contact information will be with the presentation, and I wish you a good day.